standing and walking on two legs. Going upright freed up our hands. We could carry tools, food, even babies, and scout out the savannah on the move. It also made us efficient long-distance walkers, which helped hunter-gatherers roam far and wide. But the catch is that walking on two legs twisted our skeleton in ways evolution never fully designed. Our spine had to curve to keep us balanced, and our lower back takes the brunt of that. In fact, experts note that the shape of our spine means lower back pain is very common in humans. In short, walking upright was a great trick for mobility and tool use, but it gave us a spine that aches more easily than our ape cousins. Foot and toe changes. By walking upright, we also re-engineered our feet. Our big toe evolved to line up with the other toes, acting as a powerful push-off lever when we walk or run. This stiff foot arch is perfect for stride and stamina. The downside? We lost a lot of our tree-climbing footiness. With that big toe locked in line, we're lousy at grabbing branches. Swinging around like a chimp is basically off the menu. Anthropologists point out that our human hallux, big toe, and stiff arches made us fast on land but clumsy in trees. In other words, foot evolved for bipedal running equals efficiency, but cost us the nimble, prehensile toes that would make climbing easy. Big brains versus birth canal. Human brains got huge, giving us language, art, and science. But that gold medal came with a silver lining of pain. Our skulls grew so large that squeezing a baby's head through the pelvic opening became a real struggle. We literally have narrow birth canals, a trade-off of our biped pelvis, combined with large infant heads. Scientists point out we have to be born extremely early and tiny, much earlier than other great apes, because otherwise no baby could pass through. That means human babies are born helpless, premature in developmental terms, and childbirth is agonizing and risky. One researcher puts it bluntly, our big brain has to pass through a set of narrow hips. That means we have to be born young, very young. Babies arrive on the scene less fully cooked than other mammals, which was great for brain size, but made birthing far more dangerous and painful than, say, an ape mother experiences. Brain versus gut, energy trade-off. Keeping a big brain alive takes enormous energy. Our brains burn roughly 20% of our resting calories, far more than in other primates. How did we pay for that brain feast? Evolution tilted our energy budget. In one influential idea, humans traded some of our gut for our brain. By cooking food and eating higher quality foods like meat and tubers, our digestion got easier. Over time, our digestive tract actually shrank. We have smaller guts than a typical primate our size. The energy saved by carrying a lighter gut was reallocated to fuel our supersized brains. In short, big brains gave us smarts, but demanded a lot of calories. Evolution responded by shrinking our slow, energy-hungry intestines. The benefit? A clever mind. The cost? We must hustle for high-quality food or we go hungry. Speech versus choking. Humans can speak in rich, complex languages, an obvious boon of our evolution. But that amazing vocal ability cost us our throat's safety net. We dropped our larynx down farther than in any other primate so we could make so many sounds. The downside is serious. The airway and food pipe now cross in our throat, so food can accidentally go down the wrong tube. In fact, we are virtually the only mammal that can choke to death on our food. Chimps and most other animals can't choke on their meals because their breathing and swallowing paths stay separate. By contrast, humans lowered our voice box to talk, and now we can't breathe and swallow at exactly the same time. That's why you might hear phrases like, "we have rich language," which can also literally kill us. In short, speaking gives us words and wit, but it also means an apple slice can finish off someone who laughs at the wrong time. Cooling, sweating versus wounds. Humans are world-class sweaters. Having a huge number of sweat glands, and losing most of our body hair, was a lifesaver in the hot savanna. It let our bodies dump heat and keep our brains cool during long runs or midday hunts. But this swap had an unforeseen cost. Hair follicles contain valuable stem cells that help with wound healing, whereas sweat glands do not. Essentially, In evolving so many sweat glands, we gave up hair follicles and the quick healing mechanisms they carry. Researchers note that, compared to our furry mammal relatives, human scrapes and cuts heal more slowly. In other words, hairless skin and superior cooling help prevent overheating, huge plus for early humans. But it also means a cut or bruise sticks around longer. Jaw and teeth versus diet. Ancient humans had big jaws full of large molars, including wisdom teeth, to chew tough raw plants and meats. As soon as we started cooking and processing foods, our diets got softer. Our jaws slowly shrank because we didn't need such heavy-duty chewing gear. The evolutionary hiccup is that our wisdom teeth didn't go away quickly enough. In many people today, the jaw is now too small to comfortably fit those third molars. The result is crowding, impaction, and dental misery. Wisdom teeth often have to be removed. Modern smaller jaws now mean those same wisdom teeth are basically useless and painful. Benefit of evolution: smaller heads and ease of eating cooked foods. Cost: random jaw aches and dentist visits every time wisdom teeth try to erupt. Thank you for watching. If you like videos like these, please like and subscribe.